So let's use Pascal's triangle to solve some questions. So it says expand a plus b to the power of 4. How many terms are at the end and how does that relate to your power? Now, I know we can use combinations, but 4 isn't really that big. So we have 1 and then 1, 1. And I know I could go back and look at what it is and copy it, but it's good to know how to build this. So this just splits off to 1. So our next row, that's going to be 1 and 1. Now 1 plus 1 is 2. And now be careful here. This says 4, but we actually want row 5. Okay, so it's always one more. So we're in row 3 so far. So this 1 is going to continue out. 1 plus 2 is 3. 2 plus 1 is also 3. And then that's row 4. So one more time. The 1's going to expand out. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Okay, so now we have all the coefficients. And now we can use the pattern then to do the rest of this. So a is going to be my first variable, and it's going to be to the power of 4. It's going to have a coefficient of 1. And the b variable at this point is going to have b to the power of 0. So there we go. There's term 1. Term 2 is going to have a coefficient of 4. Now a is going to decrease by 1, so it's going to be 3. And then b will increase by 1. So we get 1. Our next one, coefficient of 6. A will decrease by 1, so it'll become a squared. B will increase by 1, so it also becomes squared. Next coefficient is 4, and then a will decrease by 1. B will increase by 1, so we get cubed. And then finally our last coefficient is 1. And so a will decrease by 1, so you're going to get a to the power of 0, and b will increase by 1. Now you should not have this b to the power of 0 and a to the power of 0, because that's equal to 1. And when you do that multiplication, you just get your a to the power of 4. So let's just get rid of those. And there we go. We have fully expanded that. That's way less work than it took when I did each individual one of the binomials. But then how many terms are at the end and how does that relate to your power? Well, there's 1, 2, 3, 4, 5 terms. And it's always our power plus 1, meaning we should have 5 here, which is exactly what we got. Look at another example. So use the binomial theorem to expand 2a minus 3b all to the power of 4. How many terms are at the end and how does this relate to your power? I'm going to do this one a little bit differently. I'm going to use the combinations this time. So what's tricky is before we said we were in the 5th row of Pascal's triangle, but when I do combinations, I am going to do whatever our exponent is for our coefficient. So like if I want my first coefficient, it's going to be 4, because we're exponent 4, choose 0. And then it'll be a. And then for my next one, it's going to be 4, once the computer stops moving around here, 4 choose 1. And then we're going to have 4 choose 2, 4 choose 3, and 4 choose 4. And once these are the same, you know you're done as far as the coefficients are concerned. Now for our a's, we know this is going to be a to the power of 4, a to the power of 3. It's going to go down by 1 each time, so then a, and then a to the power of 0. And I won't write that one this time. For the b's, this one's going to start at b to the power of 0 and go up. So b to the power of 0, I won't write. B to the power of 1, b squared, b cubed, and then b to the power of 4. Now, in your calculator or using factorials, you could figure out what each one of these is. We already know from the triangle or from the last question, like this is 1, and 4 choose 1 is 4, and 4 choose 2 is 6, and 4 choose 3 is 4, and 4 choose 4 is 1. So that, in this case, maybe the choose using combinations isn't really helping us that much, but it's good to see it used in another way or done in a different way. Now this is where you got to be careful though. Your answer isn't just a cubed b. This time, a in this case represents 2a, and b is minus 3b. Now it's very important that it's a minus there. Okay, so that minus is attached to that. So I'm going to go and substitute for every a this 2a. So this is going to become a to the power, let's do this in red still. This is going to become 2a to the power of 4. And then this a is going to become 2a to the cubed. And this a will become 2a squared. This a will just be 2a. And there is no a there. And now I have to do the same thing for all the b's. So here there's no b. In the second term, there is a b. So it's going to become minus 3b. Again, that minus is part of it. And then here it's going to become minus 3b all squared. And in this fourth term, it's going to be minus 3b cubed. And our last one, minus 3b to the power of 4. Now we need to simplify that as much as possible. So here, 2 to the power of 4 is 16. And then we get a to the power of 4. Here we've got coefficients in a couple of these. So we get 8. So 2 cubed is 8. And then we got to multiply that by negative 3 and multiply it by 4. So you don't get a plus anymore. You get actually a minus 96. So that's our coefficient. You end up with a cubed and then b. Okay, for our third term, so we have 2 squared, which is 4, and the negative 3 squared, which is 9. So 4 times 9 times 6 gets me 216. And then we have a squared and b squared. Okay, for our next term, so we have 4 times 2 times negative 3 to the power of 3. So that means it's going to end up being a negative number. And you end up with negative 216. And then there's a, and then b cubed. And then the final one, it's negative 3 to the power of 4, which is 81. And then b to the power of 4. So there we go. We have expanded this out using the binomial theorem. Again, can you imagine doing this 4 times, having to do FOIL and distribute and combine like terms? Oh, so much easier doing it this way. Example 3. How many terms are in the expansion 2a minus 7 to the power of d? This question looks like it's going to be long. It's not. The amount of terms is always just one more than the exponent. So here, we got d plus 1. That's it. Question's done.